vamos então preparar-nos para falar com um dos nomes maiores na criação do ZX Spectrum. Apresentando o professor Steve Vickers, esteve sempre ligado à matemática e aos computadores. Em 1981 trabalhou temporariamente no NPL na área de programação. Seguiu-se a universidade, onde estudou matemática e mais tarde completou o seu doutoramento em álgebra, área onde voltou inclusivamente após o trabalho na área da computação. Ingressou na Nine Tiles, em Cambridge, um fornecedor estratégico da Sinclair Research. John Grant, o fundador da empresa, já tinha desenvolvido a ROM para o ZX80 e foi Steve Vickers quem a foi adaptar e evoluir para o ZX81 e posteriormente ZX Spectrum. Além disso, é um nome que nos é muito familiar por ser o autor dos manuais que tem a pintura, que está ali a ser até assinada, do John Harris, e, portanto, o manual do Spectrum é da autoria do professor Steve Vickers. Posteriormente, e juntamente com Richard Altwasser, o criador do hardware do ZX Spectrum, lançaram a Jupyter Cantab e que lançou o computador Jupyter Ace, que acabou por não ter o sucesso esperado. I'll now switch to English and please put the video on the screen. Hello, good morning.
Oh.
Hi, Professor Steve Vickers. Nice to meet you. What a pleasure, what an honor to have you here. So, thank you so much for accepting this late invitation. Also, a big thank you to Anthony Caulfield, who introduced us. So, can you hear us okay?
Just about. It's slightly noisy, but yes, I can hear you. I can make out what you're saying.
Let's do our best then. So, I have a couple of questions here, and so I'll try to go through this, but will be a very an informal conversation just to know a little bit about what you did in this area, and then try to open some questions from the audience. So the first thing, can you please tell us a little bit about your background in connection to programming? So how did you end up with Nine Tiles?
Well, I've always been on the kind of borderline between mathematics and computers. My father, Tom Vickers, he worked at the National Physical Laboratory in computers after the Second World War, and he was the person who managed the Pilot Ace, which Turing had designed. My father wasn't part of making it, but he managed it after it had been made, and he sold its services to people who needed computing. So from a young age, he used to take me into the NPL, the National Physical Laboratory, and show me the different computers and what they did. And he used to introduce me to programming languages. And I remember going to a conference with him and trying out BASIC on a timeshare machine. So I always had this interest in computing. But on the other hand, I'm very keen on mathematics. So I kind of academically, I stuck with the mathematics until I'd done my PhD in algebra. But then I kind of thought, well, why don't I try and see what the computing world is like as well? So my strategy was just to write to all the computing companies in Cambridge, and there were lots of them, see if they had a job. And the one who replied was John Grant at Nine Tiles. So it turned out they were doing Sinclair machines, which I didn't really know anything about at the time. But he had done the ZX80 and took me on to implement the maths pack for the ZX81. And in fact, I did a lot more for the ZX81 as well, just adapting the ZX80 firmware so that it would work on the ZX81. And then having done that, it seemed very natural just to progress to the Spectrum when they were doing that. And I wrote the manuals for both of them as well, because I thought, well, the ZX80 manual there wasn't much there, and I thought I can do better than that. So that's how I got into the manuals.
Okay, so I'll switch the order of the things I had planned, because that's precisely a very, very interesting thing. So when I look at the manuals from these computers, one thing that amazes me is that the authors of the manuals had to tell to the consumers what the computer could do. So everything was new. It's not like today we buy a tablet and we know what we expect to do with it. But no one had computers at home. And so I think, okay, you have that amazing work in the ROM, but your name everyone remembers because we see it printed in the book cover or the second page. So yes, let's talk a little bit about the manual. What was so did you get inspiration from any other manuals from other areas? So what were you thinking when you came up with such a lovely manual?
Well, I think it's hard to look back and think what I was thinking at the time. But one thing that I do remember very strongly is that in the manual I wanted to be telling people things that would be useful. And a big part of programming is that it's not just knowing what are the rules of the programming language or how to put the program together and get it past the compiler errors or anything like that. Programming is a creative activity, and I wanted, and I knew, because people, other members of the team were telling me that people were doing all kinds of curious stuff with the ZX81, for instance, like trying to they're poking machine code into REM statements and then running that. And I thought, wow. So I knew that to unlock the full potential of the machine so that people really could control it and use it as something for developing their own creative ideas, I knew that I had to give a fair amount of information about it that I knew, and if anyone else wanted to know it, they'd have to do a lot of investigation and finding out. So, for instance, if you think of peek and poke statements, it'd be quite easy to write a chapter on peek and poke statements that would basically say, well, you can peek a given address and find out what's in memory, and you can poke a byte to memory and get it written there, and say, if you want to know more about that, then you'll have to read another book that doesn't exist or something like that. You see what I mean?
Yeah.
And I thought what I wanted to do was show people what it was about, why peek and poke had any function at all, so that they don't just go through the manual and then find a brick wall where they can't go any further because they don't know anymore. I want to give them some indication of where are the routes up the cliff face, give them some ambition, some idea of what the possibilities are. So both the manuals, I had a chapter on the memory layout and what that meant, the fact that you've got a memory at all, because these are the things you peek and poke with. Yeah. And I had a section on the system variables, which would tell people how they could interact with the Sinclair. Well, I'll say operating system. That's a bit of a fancy term, but anyway, the Sinclair ROM. And what else? Well, I did things. I thought if they were going to use machine code, and peek and poke, you're using decimal notation. I'd have a table at the back that showed the decimal equivalents of the Z80 machine code instructions. Whereas, so you can poke directly rather than having to do the conversion first and then doing it. Yeah. So it was that kind of principle. I didn't want to say anything that was a sudden brick wall. I wanted enough explanation about the machine so that people could see what was going on and get some idea of where they could make progress in getting more control over the machine. So I hope that came out. I think, clearly people did end up doing quite wonderful things with both machines, the Spectrum and the ZX81, things that I would never have guessed.
So
it was this idea of giving them power over the machine so that they could create their own things.
It's the first time I'm talking with you, and I'm fascinated with this explanation because I think this, I would say, this orientation to the consumer, this concern you had on how to convey your message, how to transmit something, how to put people understanding how the computer works, is what made probably it's what contributed more for making of many of us programmers than anything else. Because if you did just the simple way of saying, okay, read another book or today Google it, it wouldn't work in the same way. So thank you on behalf of every teenager that eventually became a programmer like myself. Thank you for your dedication to that. I'm sure from the audience we may have some questions about some specific things, but I think we can then focus a little bit on the Sinclair operating system. Yes, please.
I can give another example because it's one I was quite proud of, and that's the beep statement. So, as you know, the sound on the ZX81 and the Spectrum is very primitive. It was just, it gives a series of clicks, and depending on the frequency, you hear different pitches. So when I looked at how the beep command worked in some other computers, I think like the BBC Micro actually, you have to tell it not the pitch of the note, which is the reasonable, the natural musical description of it, but the frequency or something like that. So it's some mathematical parameter that's correct, as it were, for controlling the sound chip, but it's not the way you write music. So if anyone wanted to program music using that command, they'd have to do a lot of calculations to convert the actual pitch into what the computer wanted. And they're just completely routine calculations. No creativity in that. The creativity is the music. And it's computers that are good for those routine calculations. So I thought, just a little bit of extra work on my part to do those calculations within the ZX81 or the Spectrum, that would really solve them a lot of trouble. And it would just unleash their creative potential. They could focus on the music, not on the laborious effort of converting it into a program. So you need some logarithms and exponentials, which is fine because the ZX81, the Spectrum, they had the ability to do those. So I tried that out. So as it's playing the music, it's converting pitch into frequencies. Unfortunately, that was too slow because the floating point calculations took just too long. So the music didn't flow. It was interrupted by calculations all the time. So I thought, well, we can still do something about it because you don't need very exact calculations to get, to make the right sound out of the primitive speakers on these machines. So I built into the beep command just a few tables, so it could do these calculations quickly, and that's what came out. So as you probably know, you can very easily code up not just tones and semitones, but also microtones, and it's all very easy. It's just in fractions of a tone that the beep command works. So it was that thought again. That was the concern with the user. I thought, just go. They say go the extra mile. It wasn't an extra mile. It was an extra couple of feet to implement this. Yeah. And it would be so much more usable, so much better a tool for unleashing the creative potential of the users. So again, it's that. I was thinking, how do I make this useful?
Yeah. Well, you're famous for another thing, and this was my final question, but I'll do it right away, which is you're famous for giving ideas to humanity, and then they came up with a solution many years afterwards. So I'm referring to your challenge of the Mahler music. So probably you can address that one right away.
Well, yeah. I mean, I was there's a tune well, it's in French actually, French tune called Frère Jacques, and my first thought was to use that as an example, because it's quite well known and very simple. And no, let's spice it up, and so I used the Mahler version in his first symphony, which is basically the same tune but in a minor key instead of a major key. And then I set this exercise as a joke, that to program up the entire first symphony, and it's a joke. I thought it was impossible because the spectrum can only produce one note at a time, whereas a symphony is full of chords and lots of notes all played together. So I just had the exercise there as a joke, and then, blow me, 30 years later, these people in Oxford, they got a whole load of spectrums together, and they had a Raspberry Pi to synchronize them to act as the conductor, and they played the whole of that movement. And I was really pleased, but I thought, what a wasted opportunity. I'd set a challenge, and then 30 years later, people had solved it. Why couldn't I have made the challenge something more useful to humanity?
If you have a new challenge to launch, I'm sure someone in the audience can start thinking of it.
So, right, yeah. Program world peace on the spectrum.
Yeah.
Yeah.
Very well. So trying to address a little bit the Sinclair operating system, the ROM. Just a couple of questions on that part, and then obviously Jupiter Ace, and then open to the audience because I'm sure it will be interesting. So on the ROM, so you picked up a previous version that didn't have a lot of things that were needed for the ZX81. Both the ROM of the ZX81 and the ROM of Spectrum were, as everything on that time, limited in terms of size. So
they were limited in terms of time as well. It takes time to develop the software. So the ZX80, which John Grant did, that was, what could be done in the time available and in the hardware available. And the time available meant Sinclair wanted to release the next machine at the next big computer fair. Yeah. And that, so the date was known in advance, and it was always a matter of, well, what can be done in that year? ZX80, ZX81, Spectrum is in effect the ZX82. Yeah. So it was always an incremental thing. Okay. So John Grant did the ZX80, and then I came in with the ZX81. So but I was interrupting your question.
No, but it was precisely that. I think you referred to that in another interview as the Sinclair product life cycle. So the always targeting the next exhibition or event. But so yes, if you can, I don't know if you can elaborate anything on the challenges of the ZX81 version, and then of the Spectrum, and specifically on the Spectrum. I had a friend giving me a question about if the 16K, I think the size was 16K of the ROM in the Spectrum, if it was something that was basically imposed by Sinclair because of cost constraints, or if it could have been a bigger ROM used or not. So if you remember any of those details.
Well, I think Clive Sinclair himself, he wasn't a computer man, but he did know a lot about electronics. And one thing he was really keen on was the cost of the electronics. And he was actually quite good at saying, oh, you don't need so much, you could make it less. And in fact, the trade-off with these machines was you could make it less by using software to do what otherwise the hardware would do. So, for instance, the Beep got minimal hardware there instead of having a sound chip in, but it's controlled by software. So the kind of the product specification in terms of cost and hardware that could be used. That was set at a fairly early stage, and there wasn't much to be negotiated with there. So right at the start of the ZX81, it was agreed pretty much that the design would have 8K of ROM, and the rest of the circuitry was designed around that, and similarly the 16K for the Spectrum. So the challenges were always how to develop the software to fit in with that. And the big challenge is just making the software compact enough. John Grant at Nine Tiles had lots of little tricks for reducing the number of bytes, and it literally did come down to how can we get an extra few bytes out of the 8K or out of the 16K of ROM. And we often found ourselves looking at questions where you say, well, it'd be nice to be able to do this as well, but that would take it to, 8K plus 10 bytes or something like that. Where can we find those 10 bytes so we can fit it in? So that was the kind of pervasive challenge.
So an optimization problem, basically, to try to optimize everything to fit in the limited hardware. I think that's probably what still makes so many people today to create games for a platform like the Spectrum, which is how to overcome the limitations of the hardware, which obviously are not. It's different when you address current hardware. So I think there was another challenge, and probably something interesting to address, which was, at least in the Spectrum, with the ZX Spectrum, which was the fact that the hardware kept being developed. So you had, I think, probably you had several access to several prototypes of the hardware that kept evolving, and that probably is what led to that existence of multiple versions of the ROM. So I don't know all the details, but so there was that. So you were working on a ROM version, but then there was at least one prototype launched with I don't know if a beta version or something. There was a slightly different version of the ROM. Is that something that you can address, and you remember any details?
Yeah, this was actually happening at the time when Richard and I left to form Jupiter Cantab. So at the end of my time there were some things that they still wanted in. So microdrive was one of those, and we hadn't got the microdrive hardware, so there was no way of testing that. And so I was trying to anticipate what might be needed for the microdrive, but I wasn't around in the end when they had to develop the ROM software to make the microdrive work, because I never had a chance to test the microdrive. Okay. So the time when your question's about, that's just the time when we were leaving. Yeah, so I don't really know what happened afterwards, how they fixed that.
When did you leave to create what became Jupiter Cantab?
We were asked that at an interview at Bletchley Park yesterday, and Richard was there as well, and he was. We were trying to remember the date, so we were celebrating the anniversary, which was April the 23rd, 1982, and he said, "Oh well, it must have been April the 24th." So I don't know how accurate that is, but it was pretty soon afterwards.
It's okay, very well. By the way, the event was interesting in Bletchley Park. Was it everything went okay?
Oh yes, it's the first time I'd seen Richard for many years, and so it's really good to see him again.
So that takes me to the last area that I wanted to ask you about. So take this opportunity to basically ask you, for those that are trying to understand everything that happened in this area, obviously about Sinclair research and the suppliers and partners. There's a lot of information. But so you work with Richard Altvasser, probably some interaction with Clive Sinclair. We know the names of Jim Westwood, Nigel Searle, others. So my question is, Any other names that you would highlight from your interactions with Sinclair Research to help us to try to identify other people to get more information about all of this?
Okay, the actual development team, Clive wasn't really part of that, nor Nigel Searle. He was
He was
he had
in the US probably. He was MD at a certain stage at least.
Yeah. So the real team for the ZX81, there's obviously John Grant, who is actually my boss. But when I went into Cambridge to work with them, the real team was Jim Westwood, who was doing the hardware for the ZX81, me, and really Rick Dickinson doing the design. And that was about it, really. And then towards the end, I think Jim was moved on to the flat screen TV project, and that's when Richard Outpasser came in.
Yep.
So he was working a bit on the ZX81, and then he rather than Jim was doing the ZX Spectrum. So it's a pretty small team, just the four of us, really. I would say we had to interact with. I mean, you'd think Rick Dickinson doing the case is separate, but actually there were rather the keyboard design had to be rather careful to implement the way you press a single key for getting a basic
matrix
command. Yeah, so we had to work quite closely with Rick on that to make sure that it was all usable when each key had, I don't know, five or six, maybe up to five or six. Yeah.
Whenever we have a child in the museum, we have one original Spectrum there that we use for that. I just ask them, please put here, load the command to load the game, and the people are not familiar with it, and then they understand how different it is, how awkward, let's say it. But it's something that we all remember fondly from the Spectrum. One final question, because before I open to the audience, tell us a little bit about your when you were creating the Jupiter race. So what was that adventure like, and if and why opting for the language Forth instead of Basic, and if things could have been different if you didn't use Forth on it. So if you could address a little bit that experience.
Well, there are quite a few small computers being developed in Cambridge at the time. So the Sinclair and Acorn, they weren't the only ones. And so we were kind of thinking there was the ecosystem would allow various computers to develop, and we could fit in with that. As it turned out, the Spectrum kind of wiped all the others out. Really, not much left. Still Acorn a bit. So what we were looking for, Richard had essentially done the hardware for it. Based on his experience with doing hardware for the others. And so what it needed were, if he had me on board, then we could get the software. So we were looking for some kind of unique selling point to distinguish us from all the other little companies around. And that's what Forth seemed to be. So I was alerted to Forth by a friend, Chris Patterson, who had already seen it, and I looked into it, and it would. So the advantages it promised were ones of both speed and compactness. The code is fairly compact, and so it's originally designed for controlling radio telescopes, and I think it was used in the first Star Wars film for controlling the special effects on that. So those did seem to be features that would make it useful for games, basically, but for other control purposes. And so that would set it apart from Basic. So that in effect was a reason for not using Basic, because all the others were doing
try to differentiate,
try to differentiate and have something better.
Okay.
It took a little bit of thought to work out how it could control not just the game or whatever it was controlling, but also the Jupiter race itself. Because in the basic machines, you can use basic as command by command just for telling the computer to do things, like load and save. You typically don't have those as part of the program. You're just using those as for controlling the computer. So it wasn't obvious immediately that Forth could do that, because the usual life cycle for a Forth program is you write all the text, you load it onto a disk, then you load back the disk, compile it all, and then you run it. So it's always edit, save, load, compile, run. And that really wouldn't have worked very well for controlling a machine like the Jupiter race. But we found ways of doing in-place editing for Forth, which was actually quite novel. No one had done that before. Okay. And so once we were happy that we could do that, then we thought, okay, well, let's go for it. So the Forth was, it had its advantages for control. We'd managed to work out how to make it work on a small computer like Jupiter race, and we thought, go for it. And I think the way it worked out, really, we had about 300 or 400 Forth enthusiasts who were just, thought that was brilliant, and they bought it, and then we kind of saturated the market. We didn't know how to take it beyond that, so that's why it didn't work out in the long run. But
there's still
we thought it was worth a try.
Yeah, there's still a group of enthusiasts of the Forth language. I know that I'm in a group with some. I know he speaks Portuguese, and they keep doing some events and invite. There's still people looking at it. I have no doubt about that. Okay, so I think we have more or less 5 minutes. I'll open now to the audience. I'm sure there will be a couple of questions. One already. So if people can help me with the microphones. So, okay, let's start with Rui Martins here, please. Here.
So, good morning. I would have two questions for you, technical ones. Basically, the ROM has some advanced features like streams or channels that were used for file or printer output. Where did that idea come from? Did it come from Unix or somewhere else? And
yeah, was I familiar with Unix at the time? I don't think I was. I'd seen other operating systems, but I didn't come across Unix until a bit later. But I'd seen about channels and things, so I was trying. That was me trying to anticipate what would happen when they eventually got the microdrive, or that's how it started. I mean, they must have adapted that software after I'd written it, but that was. I remember writing a bit of manual for that. I don't think that actually went through into the real manual, but I wanted to be flexible so that it would not just be microdrives, but would also other kind of communications between Spectrum and other machines, other peripherals, but also between Spectrum and Spectrum. But none of it ever got tested, as far as I'm concerned. I don't know what they did with the software afterwards. So I think I'm giving you a long answer to say I don't really know what the answer to your question is.
Okay. But it was very flexible and still is. The other question, quick one, was it just an implementation detail to have the programming or basic input keywords to be directly on keyboard instead of having to write them out?
Okay, that was John Grant's idea, and it was one of his clever ideas for getting the code down to 4K of ROM. Right, so if you type in LET, that there has to be some code somewhere that will check that actually is LET and then convert it into a token that means let. So what he spotted was you could do that directly if you've got a little bit of predictive text. So you know that you're at the beginning of a basic statement. You know you're expecting a keyword for the basic statement. So all you need is a little table that says that key press maps to the let token, and you don't have to do all the parsing that you would normally expect in a compiler. I mean, he was an academic computer scientist, and he knew all about compilers and parsing and that kind of stuff. So there are lots of little tricks that came from him. So that was where it started. I think it started as a way of saving space. So with the other, the ZX81, the Spectrum, there was discussion of, do we keep that or do we change it to a more normal way of interpreting sequences of letters? And I think partly in the interests of just reusing the old code that we had, we just stuck with it.
Okay. Thank you.
And with the ZX81, we certainly had to keep the code compact. So the same tricks were very useful for that as well.
Thank you. Any further question? If not, I have one. So, final question here. Oh, okay.
So, Professor Steve Vickers, thank you for being here. Quite honored to be speaking with you. It's a bit more of a testimony than a question, although public commentary would be fun. It's a small thing, but to this day, actually, so I now have a teenager at home, and he started programming. And one of the things we did, because in these days you can switch to some other activity really fast, so we gave him a Spectrum to be at his bedroom. Actually, so he cannot halt tabs. He's stuck to it, right? And these machines had this very appealing fact, which is that you immediately have a programming language once you boot the machine, right? A testimony to the endurance of your work is the fact that during COVID, he took your manual, the manual you wrote, to school every day, and he pretty much read the thing back to back. And he learned BASIC from it. So thank you for that, basically. Thank you.
Very well. So I think our time is up. So I have one final question, which I'm making to all the international speakers that couldn't come this time, which is, when do we have the pleasure of having you in Portugal? So the museum waits your visit when possible, of course.
Okay, I do go to Portugal. I've got friends there. I know people in Coimbra University.
Yeah, you mentioned that.
So next time we're in the neighborhood, we'll certainly come and see the museum.
It's 20 minutes from Coimbra, so we obviously wait for the opportunity to have you here in person. Thank you so much once again for doing this in such a short notice, and yeah, we'll go on with our program. So thank you, Professor Steve Vickers.